Mr. P's Science and Math Podcasts. For more science and math concepts, search me out on iTunes by typing Papapodcasts. You can contact me at mrplieberman@gmail.com. Thank you for watching. Parallel lines. Alternate angles are equal. So, A is equal to angle B. So if we look at alternate angles, they form pretty much this Z pattern. And that only works if we have these parallel lines. So if we have two parallel lines cross through with this transversal, okay, so what we have is this being parallel to that. We have this Z pattern, which means whatever this angle is going to equal to that angle. So here is our Z pattern. Okay, so this angle equaling that angle. And the same rule would apply if we were trying to find, let's say, another Z. And so here we're looking at a backwards Z, which would mean that this angle here would equal that angle. Okay. Now, corresponding angles are equal. Okay? So, angle E is equal to angle F. And here, what we're looking at is pretty much along this transversal, again, parallel lines with one another, but we're looking at pretty much angles that correspond with one another with respect to that transversal and that parallel line. And one of the ways to remember the corresponding is you're looking for an F shape. And this F shape, the top parts of the F are the parallel lines. The single line on its own represents the transversal. So what we have here with this example, angle E and angle F equaling one another, we have here an upside down F shape. So here's the F shape. Okay? So the inner angles that make up this F shape here are equal to one another. Okay? If we take the others on the other side here, okay, G and H, again, we are looking at this F shape here and the inner angles of the letter F. We could look at it in a different light and say, well, if we had these other angles here, if we had this angle, we know that this angle that's not labeled here is also going to be, because again, look at the F shape here. So this inner angle of the letter F here, which actually looks like the letter F, actually is also equal. Okay. But that pretty much brings us to the next point now, with co-interior angles being supplementary, meaning that pretty much what we call, and one way to remember this one, the co-interior angles, is we're looking for something almost like a C shape, but not in terms of a direct C, but we're looking at it in terms of, okay, almost a really boxy version of the letter C, which means if we were to take this angle and we would add it to this angle, we would get a total of 180 degrees. Same rule applies now with the opposite side here. If we were looking at this being a backward C, these interior angles, okay, these co-interior angles are considered supplementary. Supplementary being 180 degrees. So, as we said, the letter F, these inner angles equal to one another. If we have the letter C, these inner angles equal to 180, so they're supplementary. Okay. Now, in another note, okay, in another side note, from what we saw in the previous, we were looking at opposite angles. So if we have here, look at how the lines here cross one another, which means whatever this angle is going to be equal to whatever that angle is, which means whatever this angle is will equal whatever that angle is. So that just pretty much kind of does a little quick review of what we did in the previous slide. Congruent figures, okay? So, congruent figures have the same size and shape. So, here we have triangle ABC and triangle DEF. So, in triangle ABC is congruent, okay? So, this symbol here means congruent, okay? So, triangle, because that's what the shape of the object is, and we're using the letters that make up the triangle. So triangle ABC is congruent to triangle DEF. Okay, and how do we know that? Well, or how do we show that? Well, the fact that side AB is pretty much equal to side DE. Side BC, okay, let's use a different color here. Side BC is equal to side EF. Okay, and side CA or AC, however you want to label it, is congruent to angle FD or DF. So because we know AB and C is congruent to triangle DEF, and we proved it by using, the fact that, the sides are equal to one another, then that means even the angles must be equal to one another. And here, whenever you see this, so notice here we've used the shape, this shape, and we've used this shape. Here we're representing the triangle. Here we're representing the angle. And in terms of this angle, whatever is the middle letter, whenever we use this angle symbol, whatever is the middle letter is the angle that we're talking about. So if we're looking at this example here, angle ABC, this angle B is the vertex of that angle. So we're really looking at this angle here. So they're saying that this angle is equal to this angle for this example. For this next example, B, C, and A, the vertex we're looking at is angle C, which means it's equal to angle EFD, F being the vertex. Okay. And lastly, CAB, angle CAB, the vertex is A. Okay, so we're going from C to A to B is equal to angle F to D, which D is the vertex of the angle that we are looking at, is equal to that.